So I had a video a while ago where I did a part, edited, and defined in the context of an assembly that it was in. And I talked about that this way can be a huge help. It also could possibly lead to some problems down the road. And I didn't really expound on what the problems were. I had a question from a viewer that asked, what are the do's and don'ts, or what should we avoid with in-context editing? I'd like to cover that here. Now, what I go through in this video is not unique to Alibre. Any parametric platform that has this functionality, like SolidWorks, is going to have the same or very similar issues with in-context editing. All right, this is kind of universal across the board. And I have a video on SolidWorks about rebuild errors, and I have a few references to this problem. So in Alibre, I'm going to select and sketch on a plane, and I'm going to create a very simple part. We'll use symmetric to make sure that the origin is in the middle of our part here. And let's create a part that will allow us to explore in-context editing, the pros and cons, the do's, the don'ts. Let's create a sketch fillet now. Let's create a sketch fillet now from here to here. All right. Let's add a dimension. From here to here, say we'll make 6. We're going to say equal from here to here. And then let's add 4 circles, right? These are going to be holes when we extrude this sketch. So I'll choose vertical from here to here, and vertical from here to here. And we'll choose horizontal. This is making sure that our holes are good. We're going to make an equal so that they're all the same size. And then we need to add some dimensions. 3.5 by, let's go with another 3.5. We'll add a dimension to give them a radius. Let's actually make them big, right? 1.5, big holes. And then I'll choose, how about a symmetric sketch, right? We'll choose this line and these points to be symmetric about. And we're fully defined, so we'll deactivate the sketch and we'll extrude this 1 inch, right? So there's our part that we'll start out with. I'm going to save this. Holes video version. And if I really want to be neat, maybe I can demonstrate something about this. Let's change this to mid-plane. Right, so now we're right in the middle of that plane. The origin is dead center of the part. We've saved that. Let's do a save as. I'm going to save this part as Peg's video version. And I'm going to edit my sketch, and I'm going to delete. In fact, I can just create a big square that encompasses all my circles. I'm going to hit the delete key, deactivate my sketch, and I've deleted all of the holes in my part. And this will be Peg's. We'll save that. Now, let's create an assembly between the two. We're going to say new assembly. Here's my new assembly environment. We'll insert holes, video version. Now, if I just click on the origin, which I think is a great place to click for your very first part, and then say finish, notice we're oriented the exact same way, right? So we have this part aligned with all of our assembly planes the way that we had constructed it with all of its planes. I like the consistency, although it's probably not as important as I would say it is. Let's insert another design, and we're going to go with our pegs video version now. So I could just edit this part and have some pegs on it, right? Maybe I can demonstrate that real quick. So we're going to edit in separate window. All right, so I've made a sketch that is pretty much the same thing as before. I didn't want to waste your time because you don't need to follow along here. But this is just an example of how I define a sketch without in-context entities, right? We're going to extrude this to 1. Maybe we'll highlight each of these faces and choose chamfer, close. All right, so we're going to save and close our window here. So now I would just go to New Constraint, add geometry here, and here, and here. Right, so we have 4 holes in one part and 4 pegs that line up. Now what if I go to my hole part and I edit the sketch of my holes so that this becomes 2.5 and maybe this becomes 2.75, right? Our holes don't line up with our pegs. Well, we would tell ourselves, and I can right click here and edit my assembly again. We would tell ourselves, wouldn't it be nice if the pegs automatically updated to fit the holes? And this is where in-context story begins. I'm going to edit my sketch, and let's start with a clean slate. So what I can do is, right, I'm editing my part that has the pegs on it. I'm sketching on this face that I've created my pegs. Let's now project all the circles from our other part into the sketch. We're going to click this Maintain Association so that these are kind of permanently fixed. They can't be edited. Let's right-click on these and make sure that they're for reference. And now I can choose the centers of all the holes that I've imported. And I can define this in a completely different way. Instead of using dimensions, I'm using references from my part to define the locations of my pegs. That means that if I change the locations of these holes, the locations of my pegs are driven off the locations of my holes, and they'll update automatically. I'll make this kind of small, maybe 1.25. And we'll deactivate our sketch, and we'll generate to our last feature. All right, so we've updated adequately. So now we're back in the assembly editing environment. If I go to adjust the location of my holes once again, and I go to edit my sketch and we make this 3.25, you can see the original location of our pegs still, 3.5. We'll deactivate our sketch, and right as we deactivate, our pegs have already updated to be concentric, right? What a luxury that now I can edit the locations of my holes and my pegs update automatically. It also goes to say that when I make my part that has the pegs, I don't have to recall the dimensions of my holes. So it's a huge time saver that if I've made 100 parts and I'd have to go look up the dimensions of my holes to make sure the dimensions of my pegs match up, I don't have to do that with in-context editing because I can reference the dimensions of the holes immediately. So what are some problems that we come across with in-context editing? Let's start by making an edit of our part, right? So I edit one of my holes, and let's hypothetically say that as I edit the sketch to my holes, I want this hole to be non-existent, right? Let's change this to a reference figure. We're going to deactivate the sketch. First off, you can see that I still have my peg kind of peeking through my face here, and it doesn't reference anything anymore. So if I go to change the dimensions and I make this something like 2 and 2, where these holes become very close together, I still have this peg out here that references nothing, and it's not very good. Right, so there's my 3 pegs, and this peg now references nothing. If I go to edit the sketch on my peg, we can still see that we have our imported geometry, but it's no longer connected to our hole because our hole was suppressed. And so it's just hanging out here, kind of broken. So one problem is when you edit features, you can affect the features of the other part in this manner. An easy way to fix this, of course, is if we edit our whole part. And we edit our sketch, and we change this back to a regular figure, and we deactivate, everything snaps back into place because it now recognizes the hole, and the links that were associated are restored. Another way is to delete the features that are broken if you don't want them anymore, right? That's also easy. But, of course, when you're dealing with really complicated parts and really complicated assemblies, it may be a little bit more painful to do so than what you've seen me do here. Here's another possible thing to look out for. I may still want to have 4 holes. And if I edit my whole part, let's say somewhere in my editing process, I delete a circle, and then I add my circle back, and I make sure that this is equal, and we are vertical, and we have a horizontal constraint, and I think we need to re-add an equal over here, which is fine. And we're going to deactivate, and everything looks fine, right? I deleted something, but then I added it, and I rebuilt everything, and everything is the exact same as it was. And I have the same design intent. So you may be asking yourself, what is the problem? If you know what the problem is, you're very astute. Let's go to edit our holes again, just to verify. That we have the same design intent, right? I can say 3.5 and 3.5, right? Everything updates as it should. So what's the problem? Well, that's the problem. Our peg did not update to our hole. So when I deleted a circle and replaced it with a different circle, the references attached to the hole that circle generated were deleted with the sketch circle that I had deleted. Now, when I added a new circle, the position reference of this peg is not attached to the new circle that I sketched in. So the peg remains in its regular position. Now everything looks fine in the tree until I go to edit my assembly again. And still everything looks fine until I go to enter design relations, right? And I've got a broken relation right here. So our interdesign relation, these are basically the concentric relations that I added in between the two parts to make the pegs. And our interdesign relation is broken. So I can just delete this interdesign relation, and that there's nothing wrong with doing that. But if I want to actually fix this because my relation is broken and gone, I have to re-edit. So I'll go to my PEG video version. I'm going to edit this. Right, I'm going to edit my sketch. And there's my broken relation, or my broken imported line, right? I have to delete that. I have to project a new reference figure here with maintained association. And now I have to say concentric from here to here. And again, the sketch is fully defined. I'll go back to edit my assembly. And now we have no broken inner design relations, right? I had to go back and manually add that relation. I seem to have forgotten to roll my part forward, so we'll generate the last feature to get our chamfers in there. And now I can run a quick test. Right, I can edit my holes once again and change their position to be 2 and 2.5, let's say. We'll deactivate, and our pegs, of course, update to those holes. So, the moral of the story is, in context editing, it saves you from having to look up the dimensions of other parts to get them correct. You can just reference the positions of features of parts that you wish to reference, and it saves you a bunch of time. If you make changes, it saves you time because your parts are linked, and they'll update to the part that you edit. Saves you time. Saves you a lot of thinking. The downside is if you do major edits, you can have some broken links in between parts. Hopefully I've sufficiently demonstrated that, and hopefully that answers the question as to some of the traps that you can fall into when it comes to in-context editing. Alibre has great topology naming. It's pretty rare that, I don't think I've ever had a topology naming error with Alibre, but that's always a possibility that happens. So I hope this was helpful. If it was, please subscribe. I'll see you in the next video.